Hi, this will be a series of recorded lectures on conducting geographical investigation in weather and climate. Today's session, session 2, will look at the fieldwork stage. In this stage, the collection of data can take the form of recording observations, taking measurements, and sampling methods and interviewing respondents. For the third form on sampling methods and interviewing respondents, it will not be covered in this session as this is mainly for tourism GI. In recording observations, this can be done through 4 methods. They are recording sheet, annotated photographs, maps, field sketches. And we will now briefly look at each of these methods in recording observations. Firstly, in a recording sheet, it provides a systematic way for researchers to record their data and relevant observations, usually in a table form. The main purpose is to allow the researcher to record their information easily and conveniently when they are out in the field. In the design of the recording sheet, you can refer back to your hypothesis or guiding question, or look at the context of the fieldwork and scenario to pick out the variables that is to be collected. An example of the recording sheet is shown here, where it makes data collection more organized and will be useful in the post-fieldwork stage, where you are presenting the data in graph or other forms to facilitate the analysis of data. Next, another way to record observations is through annotated photograph. It allows the researcher to capture the visual image of the field study sites and include relevant description of features that are relevant to their study. Annotations can be especially useful in the post-fieldwork stage, where one tries to make sense of all of the data collected. So, what is the difference between annotations and labeling? This is an example of how an annotated and labeled photograph looks like. As you can see from the photograph, labeling will be the naming of features that is relevant to the researcher, while annotation refers to the naming of features with the addition of a short description on how it is relevant to the investigation or the variable they are studying. Moving on, we will now look at maps as a form of recording observation. In the use of map, it shows the location of physical features and human activities, and it can also be used together with annotations to provide short descriptions of the location of the recorded data. Similarly, this form of recording will be especially useful after fieldwork in the analysis of data. In the use of maps, it is also important to take note of the map elements, as this information can provide greater clarity in making sense of the map and the nature of information shown. Lastly, field sketches is another way of recording observations on your fieldwork site. The use of field sketches allow you to record features at your fieldwork site through the act of sketching. As opposed to a photograph, the act of sketching allows the researchers to select and take note of key features of the surrounding and include it in their sketches. This is in comparison to the use of photograph, which may have a lot more information and may be less focused. In the drawing of the field sketch, researchers will sometimes use a rectangular frame that divides the picture, the surrounding, into 9 grid boxes to facilitate sketching. This is an example of a good field sketch. As you can see here, certain key features are highlighted in this sketch and labeled as well. This allows someone who is looking at the field sketch to be clear on what to take note and pay attention to. Moving on from recording observations, we are now going to move on to a more technical aspect in weather and climate data collection, which is the use of instruments to collect weather data and measurements. We will briefly look at each of the instruments used for the various weather data. We will also look at various precautions and considerations in the use of these instruments and how it could be used. After which, we will then look at some general considerations in the collection of measurement readings to ensure that the readings taken are accurate, consistent, and valid. So, in taking measurements, as said earlier, these are the 3 key things that we'll be looking at. In the collection of wind data, which can be understood in terms of wind speed and wind direction data, the 2 instruments to collect this data will be the wind anemometer, used to collect wind speed, and the wind vane, which is to collect wind direction. In the use of these 2 instruments, take note of the precautions on how this instrument should be used to ensure accuracy. Generally, for wind data, instruments should be held away from your body to prevent any obstruction of the wind flow. Similarly, it should be positioned in a place that is open as far as possible to prevent any obstruction of wind. Another thing to take note, especially for the wind vane, will be that the wind vane points to the direction to where the wind is blowing from. Next, for air pressure data, the instrument used is known as an aneroid barometer, seen here. And this instrument has 2 needles, one known as the movable pointer to mark the current air pressure of the place, and the measuring hand, which will change accordingly due to changes in pressure. To obtain the current air pressure reading, you will need to look at the measuring hand. Some precautions to ensure that this instrument is used accurately will be to ensure that this instrument should be placed in a Stevenson screen or not facing direct sunlight to prevent it from affecting the reading. Second, the reading of the measuring hand should be directly above it to prevent any parallax error. What do I mean by this? So when you have the reading, it should be read directly above here instead of any points here or here that can cause parallax error. So what is a Stevenson screen? A Stevenson screen is a shelter or a container to protect weather instruments from precipitation and direct sunlight, and at the same time to ensure good ventilation. So as you can see from this picture, there are certain key features of the Stevenson screen to ensure that these instruments are protected and allow accurate reading. Firstly, the presence of loops and holes here ensure good ventilation and circulation to prevent air from being trapped inside. Second, the Stevenson screen is painted white, as you can see here, to reflect heat away and to minimize the amount of heat absorbed by the container. Lastly, the Stevenson screen is usually at least 1.5 meter above ground to prevent heat radiated from the ground from affecting the temperature. So what are the instruments commonly found in Stephenson's screen? They will be the thermometer, aneroid barometer, and the hygrometer, which is an instrument used to measure humidity. So in summary, the Stephenson screen is used to collect temperature, air pressure, and humidity data accurately by preventing precipitation or direct sunlight from influencing the accuracy. I think you should be able to understand why weather data such as wind and rainfall should not be placed inside the Stephenson screen, as it will result in the inability to collect any of this relevant data. Moving on to temperature data, the instrument used could be an analog or a digital thermometer. And some precautions to ensure that this instrument is used accurately will be, firstly, do not hold the bulb of the thermometer as seen here to prevent your body heat from affecting the reading. Similar to the Stephenson screen, it should be held at least 1.5 meters above ground to prevent any heat radiated from the ground in influencing the accuracy. Lastly, for an analog thermometer, it should be read at eye level to prevent parallax error. Another instrument used to measure temperature would be the maximum and minimum thermometer. Here, these instruments, apart from current air temperature, it also records the maximum and minimum thermometer by observing the lowest point of each metal index. For example, the maximum temperature can be obtained by looking at the bottom of the metal index on the right-hand side of the thermometer. The minimum temperature can be obtained by looking at the metal index on the left-hand side of the thermometer. With both the maximum and minimum readings, we will be able to obtain the daily temperature range or diurnal range, which in this case, in the picture, it will be about 5 degrees, based on the maximum and minimum temperature recorded here. Also, the maximum and minimum thermometer can also obtain your current air temperature by reading the top of the mercury column at either side of the thermometer. The mercury column will refer to this portion here, the gray portion here. Next, for relative humidity data, it will be collected using a sling psychrometer as seen on the screen here. The sling psychrometer consists of two thermometers, one known as the dry bulb thermometer used to measure air temperature, and the white bulb thermometer, which is covered with a wick to measure the rate of evaporation. The series of information here shows you the steps on how you could obtain the RH reading or RH data through a series of steps. Some precautions to ensure that this instrument is used accurately will be, firstly, to read the wet bulb first, as the wick can dry up with a delay, which will affect the wet bulb depression. Similar to the thermometer, it should be read at eye level to prevent parallax error for both thermometer readings. It should also be placed away from your body to prevent your body heat from affecting the readings. For precipitation data, it will be collected using a rain gauge. Here, the picture shows the different components of the rain gauge, and similarly, it shows how you could go about using this instrument to collect rainfall data. The thing to take note in the collection of rainfall data will be it should be done as soon as the rainfall event ends to prevent any evaporation of rainwater that can affect the accuracy. Apart from that, other precautions will include to be will include that the instruments be placed in an open area without obstruction. It should also be placed on a grass surface instead of concrete to minimize the amount of backsplash. It must also be placed 30 cm above ground with it partially submerged to ensure stability and to prevent it from toppling. Lastly, it should be read at eye level for the measuring cylinder to prevent any parallax error. After covering all of the different instruments used to collect the various weather data and how to ensure its accuracy, there are also some general considerations when we take measurements to ensure that it is consistent, accurate, with minimum error. As seen on the screen here, will it be consistent and accurate if both of them were to take turn and record the temperature data? It may not be consistent because being different in height could affect the consistency of the reading, as the height in which the thermometer is held can be different. To reduce this issue with consistency, one can decide on a fixed height in measuring the temperature. For example, for these two persons in recording thermometer reading, they could all agree that it should be held 1.2 meters above ground, regardless of where they hold it, to ensure consistency. What are some other general considerations? Firstly, repeat your measurements at the same locations and take its average to minimize errors and reduce bias. You can also take measurements across more timings, for example, in the morning, afternoon, and evening, to ensure that this measurement is a better representation of the place. Lastly, you could also increase the time frame of your study. For example, doing it over 3 days or a week instead of 1 day to ensure that the data is more reflective and reliable. Moving on to why there's a need to take average. By using the example here, you can see that by taking more readings and finding the average, it reduces the error in the measurement, as reflected in the outlier of 36, seen in both tables. This is where, for table 2, with 7 readings taken and the average calculated, the average reading is a better reflection of the other readings taken. In comparison to table 1, with only 3 readings taken, the average is more inflated as a result of the outlier because of fewer numbers of readings taken. So in summary here, the point of taking average is to actually minimize your errors in calculation with outlier values as seen here, and to also ensure that the average is a more reflective number of the other readings that you have taken. In summary, what have we done for session 2 is we have first looked at the different methods of how observations can be recorded. Next, we have also examined the use of instruments to obtain measurements of the respective weather data. We have also looked at the general considerations in ensuring readings taken are accurate, consistent, and valid. In our next session, with the collection of relevant data, we will now move on to session 3, which is the post-fieldwork stage, where we will analyze, present, and form conclusions to your GI. With this, thank you for your time, and this will be the end of session 2 recorded lecture.